Today, this is 15th lecture in the webinar series of our college. Our today's speaker is Dr. B.R. Sapkal. He is from VNIT Nagpur. I cordially welcome on the behalf of college Dr. B.R. Sapkal. Sir, welcome, sir. I would like to introduce Dr. B.R. Sapkal in a very short manner. The name is very familiar to this institute. He has visited during the National Conference on Physics to this campus. Research scholar. So far, 13 students has been awarded under the able guideship of Dr. Sapkal, and 3 students are doing PhD under his guideship. Up to this, near about 132 research papers has been published by Dr. Sapkal in national and international reputed journals. Many more his research papers are having impact factor more than 10. This is a very big achievement. We know that. Dr. Sapkal has served in many institutes. He was also in North Maharashtra University, Jalgaon, and he also served in Shivaji University, Kolhapur. Again, he served in University of Wisconsin, USA, Gifu University, Japan, Hanno Mentor Institute, Berlin. He holds different administrative abilities in VNIT Nagpur, like he was Associate Dean for Science Faculty. He is Head of Physics Department in VNIT Nagpur. He was Chairman of Board of Physics and also a Senate member. Up to this, 7 major research projects has been completed by Dr. Sapkal, and near about 2 crore 12 lakh and 2 crore 12 lakh 67,000 rupees grant has been procured from DST and UGC. His work has been appreciated by number of institutes at national and international level and awarded for 7 times. JSPS award, that is Japanese award, is awarded for him. Outstanding work presentation award, and so many such awards has been on the name of Dr. Sapkal. The achievement is that Dr. Sapkal has been nominated for Shanti Swarup Bhatnagar Award in 2018. With these short words, I welcome Dr. Sapkal for the webinar series of our college. Today's his topic for speech is Basic of Semiconductor. I request Dr. Sapkal to start his lecture. Dr. Sapkal, please. Chitte sir. Chitte sir.
Abhay, hello.
Chitte sir.
Abhay.
हो.
अरे तिथे अभय
बोला सर.
अरे ते सर नाही आहेत, डिस्कनेक्ट झाले तसं वाटतंय. आता लक्ष दे, संपाल नाव आहे सरांचा खाली.
हो सर.
इन करला वेटिंग मध्ये असतील बघ.
नाही आला.
डिस्कनेक्ट झालेत ते.
हो हो.
Friends, Dr. R.S. Patil, Principal of Shahada College, is also today in our webinar series. On the behalf of college, I welcome Dr. R.S. Patil, sir.
सर
सर फोन करा बरं त्यांना.
अनिल पाटील बोलतोय सर नाव. बरं त्या आयडी वर चालू करा. ओके ओके सर. ओके सर डिस्कनेक्ट झाले, येत आहेत 2 मिनिटात येत आहेत. यशवंत सर.
हो.
यशवंत सर.
हो.
साक्री कॉलेज प्राचार्य डॉक्टर आहिरे पण आहेत.
Okay. Friends, Dr. Rajendra Ahire sir, principal from HGP College Sakri, is also in our webinar series today. On the behalf of college, I welcome Dr. Ahire sir.
चित्ते सर.
हो सर.
त्यांची रिक्वेस्ट बघा, रिक्वेस्ट करतायत सर.
हो आले.
येस सर.
हॅलो.
येस सर.
हा येस. हॅलो
सर बोला सर, येतो आवाज.
हा. वन मिनिट. तुमची स्क्रीन जी आहे ती ऑफ करायला लागेल, मग मला ते शेअर करता येईल.
जस्ट मिनिट. चित्ते सर.
हो सर.
चित्ते सर.
हो सर.
सेटिंग मध्ये जात.
सरांची स्क्रीन शेअर करायची ना.
हो, तुमच्या सेटिंग मध्ये बघा तिथे.
त्यांना काय लावा सर शेअर. सर तुम्ही शेअर करा सर, सबका सर.
नाही, तिथे ऍक्च्युली तुमची स्क्रीन दिसते.
चित्ते सर.
हो.
सेटिंग मध्ये जा तुम्ही.
हो
सर केलंय मल्टिपल पार्टिसिपेंट्स.
2 मिनिट. हॅलो.
नाही, ती तुमची स्क्रीन दिसते. मी करू का शेअर?
हो सर, तुम्ही शेअर करा ना.
हा ठीक आहे. आली का? सर स्क्रीन आली का?
2 मिनिट. येस सर, येते. 2 मिनिट. येस सर, कंटिन्यू सर.
ठीक आहे, चालू करू?
येस सर. चालू करा सर.
हाँ ओके. Hello. Okay. Good morning to all of you and thank you very much for the nice introduction. Here I wish to give you some basic things regarding the semiconductor, because although you all students belongs to the rural background, so it is necessary that to understand this semiconductor, which belongs to the physics, which is an essential part from the physics studies. So here, our institute, that is VNIT, it is an institute of national importance, which is a central government body and autonomous institute, and it is funded by MHRD. And we have three branches: engineering, architecture, and basic sciences. And here students are coming after 12th for BTech, as well as after BTech they are coming for MTech and PhDs. And we have basic sciences like physics, chemistry, and math. And our institute, they are providing fellowship to the PhD, MTech students, and we have also humanities department. Sound is it clear?
Yes, sir. Yes, sir. Please continue, sir.
Okay. So here semiconducting materials are there, right? Then if you have the material or any solid, that can be divided into three major parts. One, it is called as a semiconductor. Second one is called as an insulator, and third one is metal. So all these materials or three forms of the material that can be categorized depending upon its conductivity. So conductivity, it is a major role. So that we, before going to detail about the semiconductor, first we have to understand little bit the band theory, right? So if you understand the band theory, then we can go for the semiconductor, and then it is easy. So whatever the materials or solids are there, that can be divided into three parts. That is the semiconductor, metal, or insulator on the basis of the conductivity. So conductivity plays very important role to categorize these materials. So if you think about the conductivity, just here I have categorized as a conductor, semiconductor, and insulator, and you know that lot of materials are there, but still there is another one category called as a superconductor, whose resistivity can be very low, right, at low temperature, or we can say zero at low temperature. So conductor means what? It is possible to carry the current, so it is having mobile charge. And semiconductor means what? Its conductivity lies that of the insulator and metal. And insulator means what? It is having very high resistivity or very low conductivity, or in some cases there is no conductivity like plastic, or maybe you are taking wood. Right? These are the different conductivity range, or we can say resistivity range. Conductivity, it is just the reciprocal of the resistivity, and these are the materials which are already categorized so that you can see the resistivity in ohm meter and the conductivity, right? So these are all data. This one is available on the internet, right? Whenever you are thinking about the metal and conductor, if you want to differentiate that one on the basis of the suppose resistivity, then you can play with impurity concentration, temperature, light intensity, right? And this graph shows how this metal can be differentiated with the semiconductor depending upon its resistivity with respect to the concentration, temperature, and the light intensity. So in order to understand this basic phenomenon, we have to just understand the band theory, and we have to understand then the semiconductor. So band theory of the solid, it plays very important role in order to account the increase or decrease in the resistivity with respect to the temperature. As you can see that the metal, it is having positive TCR, that is the temperature coefficient of resistivity, whereas the semiconductor, it is negative TCR, that is the temperature coefficient of resistivity. Means what? In case of metal, if you increase the temperature, the resistivity goes on increasing because of the lattice vibrations. But whereas in case of semiconductor, if you increase the temperature, the resistivity drops down, right? But you know, in order to understand this one, we have to go through the band theory of the solid, where there is a called forbidden gap, because as you have seen that forbidden energy gap, that in semiconductor some gap it is there, in insulator large gap it is there, and in metal gap is not there. So how to understand this process of the forbidden energy gap on the basis of the band theory? So in order to understand this one, we have to see about the atomic interaction, and that is the most important part inside the band theory of the solid. So whenever you are thinking about the atomic interaction, this nature of the energy bands that determines the property of the solid. This is very, very important. That is the energy of the band which determines the property of the solid, whether that band it is filled band or empty band or partially filled band, or whether that energy gap it is there or gap between the bands it is there, and the most important factor it is density of state. Today we are not going to discuss in detail for this one because of the time restriction. So in order to understand these things, there are three important parameters. Whenever you are understanding the energy band, there are three important parameters. One is called as the orbital quantum number, that is called as L. Then depth of the atomic interaction and the interatomic spacing. So these are the important parameter. I think whatever teacher may be going into the class, maybe they are looking to the band theory but not as this slide. So these are the important things whenever you are understanding the energy band. These are the quite important whenever you are studying the band theory of the solid. So orbital quantum number, depth and interatomic spacing plays very important role, because when atom in the crystal interact, the extent of energy level is important, and there is an interaction which leads to the splitting of the energy level, right? And whatever the degree of interaction it is there, that is also important while splitting of the energy level it is considered. So interaction is proportional to the atomic spacing. Then if you are thinking about the orbital quantum number, just think that number of atoms can come close together. Then just in order to understand this one, we can see that when atoms come close together, they try to interact. And you can see that atom it is surrounded, atom it is there where orbital electrons are there. These are surrounded to the nucleus. Means it starts to interact from the outer shell and it will interact to the inner shell as well. So here, this is important parameter inside the band theory, that is the orbital quantum number. As you know that if you are considering the orbital quantum number as L, it can take the value 0, 1, 2, 3, 4, depending upon the type of the orbital, whether it is S, P, D, F or G, right? So just to understand this one, we can consider the n identical atoms that has approached to each other, and we can say that H0, that is the actual phase spacing between the atoms for a particular solid. Means, for example, if you are taking the copper, right, atomic interaction or actual spacing between the atom, it is fixed, that we are not going to change, right? So that belongs to the copper. Then here we can actually just have to understand the 10 electrons, so that it is having electronic configuration 1s2, 2s2, 2p6. That belongs to the 10 electrons. So, but still I have kept the next one, that is 3s0, although no electrons are there. So how interaction it is there inside this case. Then in order to understand this interaction, I have plotted these two diagrams, that is the energy against the isolated atom. This is the energy level for the isolated atom, that is the interatomic distance it is there. Then energy level with respect to interatomic distance when you are considering two or more atoms, those are bringing close together, right? For the sake of understanding, orbital quantum number L, it decides the number, that is twice L plus 1 into n, that is these are the energy level of the inside the specific level, right? Then here it can take the value 0, 1, 2, 3, 4, depending upon what type of orbital it is there, S, P, D, F, G it is there, right? S belongs to the 0, P belongs to the 1, D belongs to the 2, right? And now we can see that how this 10 electron, it can split, right, the energy level when you are taking different number of atoms bringing close together. Then for a single atom, we can say that it starts to interact from the outer shell, right? Just we can have in this case, that is it starts from 3s0. Although there are no electron, but still there is an interaction and splitting of the energy level is there. And this is the important aspect is there that you have to understand. Although in the last thing, 3s0, there are no electrons, because here we are considered only 10 electrons. And although 3s it is there, no electrons are there, still if you are taking number of atoms comes close together, still interaction it is there. So depending upon S belongs to 0, right? L equal to 0, so S takes the value 0. Then we can put down the value inside twice L plus 1, that is L equal to 0. So that 2 into 0 plus 1, it gives the 1n level. So 1n energy level it is there. So how many electrons are there? That is the twice n states are there. But here actually it has to occupy 2 electrons. Right? 2 electron means what? It is the 2 quantum states. One is spin up and second one is the spin down. That is the 2n quantum states are required right? So it is spin up and spin down, twice n energy levels are there. So although there are no electrons, still it can split. The next one, it is L equal to 1 for the 2p orbital. So that we can see that twice L plus 1, that L equal to 1, that is equal to, we can say that twice L plus 1, it gives the 3n energy level. So it is having 6n states, so that it is having 6n electrons, right? Then next one, it is 2s, because it starts to interact from outermost. So L equal to 0, so that here I can write again 1n energy level. So twice n states are there, twice n electrons are there. And last one, which is close to the nucleus, which is 1s, so that again it can interact, L equal to 0, twice n states are there, twice n electrons are there, right? So these are the interaction it is there. It's depending upon how the orbital quantum number it is there, right? So we can say that as this electrons, it is 10, valence electron, it is up to this valence electron, it is completely filled, and the 2s0, it is empty, no electrons are there, and we can say that may be conduction band depending upon the type of material. So here valence band it is completely filled, or conduction band it is completely empty. So next one, it is the depth of the atomic interaction, occupancy of the band by the electron. So important thing is that there are different quantum numbers that specifies the atom, that is n, l, m, and s. That is the principal quantum number, orbital quantum number, magnetic quantum number, and spin quantum number, right? So how it is used, that is n is the principal quantum number, l is the orbital SPDF, p, that is magnetic quantum number, it defines the px, qy, pz, and s is the spin, whether it is spin up or spin down. Generally speaking, the principal quantum number determines the size and energy of the orbital. As n increases, the size of the orbital increases. L determines its shape, that is s orbital, then it is rounded. If p orbital it is there, it is having dumbbell shape, and d orbital it is there, it is having twice dumbbell shape. And m determines the orbital interaction. If you are considering this just p, then it is along px, py, and pz, that is along x, y, and z. As we know that Pauli's exclusive principle, that no two electrons have the same fourth set of quantum numbers, right? So each electron has a unique set of the quantum number, and this is very, very important. So depending upon that one, how the electrons are filling the orbitals, that it is having complete shell, as this one is well known. So that complete shell for the first one, it is 1s, then next one 2s and 2p, next one 3s, 3p, and 3p. So how this shell it is filling, that is the twice n square, that relation it is well known. So depending upon that one, that shell it is filling. So that if you are taking the K shell, L shell, M shell, N shell, and O shell. So K shell it is having 1s2, then L shell it is there, two things are there, L1 and L2, that is 2s and 2p are there. Then M shell it is there, 3s it is there. So for K shell it is 2, L shell it is 8 number of electrons, and M shell it is there, that is 18 number of electrons are there, which can be filled inside this shell, right? These are the well-known examples that we can see. So filling of the energy level, whether it is completely full or whether it is completely empty, or it is partially filled or vacant or empty, that specifies the type of the solid or material it is there. Here we can take the general thing, that is the sodium, it is belongs to the Z equal to 11, right, which specifies the electronic configuration 1s2, 2s2, 2p6, and 3s1. So we can define whether it is metal or semiconductor, right? So here we can say that 1s2, 2s2, 2p6, these are the bounded electrons, and then 3s1, it is free electron, and this free electron is there, which gives the conductivity in case of metal, and sodium it is a metal, and this number of atoms are bringing together, then it is having n, this 10 to 28 atoms we are considering in 1 cubic centimeter, then we can have a lot of electrons inside that one, which is required for the conduction. So we can differentiate that one depending upon that one. So completely filled, which is bound, we can say that valence band, and which is free, which can called as a conduction band. But here, these bands are close to each other because of the splitting of the energy level. But here we cannot understand how it is there, why it is a conductor. But on the basis of the energy band diagram, we can understand that one. So this coupling, it is most important parameter, that is the interatomic distance, which is a constant for a crystal, and strength of the coupling depending upon how much E2 minus E1 it is there. And for sodium, it is fixed, that is whatever value of E2 minus E1 it is there, depending upon how the energy level it is there, right? So here splitting of the energy level plays very important role. We have to understand that one, and we can classify the solid depending upon that one. We can specify the electrical conduction in the solid. So classical theory, it gives the electrical conduction that can occur in a solid which 3 electrons are available. But band theory, it says that there are two important things. A good number of free electrons should be available, and vacant levels adjacent to that occupied energy level should be available. Right. So in case of metal, these energy bands are there. Either it is completely filled and completely empty. That should be adjacent, or it can be overlapped. That is, the energy gap between this band is equal to 0. That is no energy band gap in case of conductor. Right. So in case of metal, this is either overlapped or very close to that one, completely valence band, completely empty conduction band, but there is no gap. That is the most important inside this one. But whenever you are thinking about the semiconductor, at here we can see that there is a gap between valence band that is completely full and conduction band that is completely empty, right? So here we can say at normal temperature, this semiconductor, we can say it is a semiconductor, but at absolute zero, these are the insulators. Right. So here we have to understand this semiconductor that at low temperature valence band it is completely filled and conduction band it is completely empty. So conduction band it is there and valence band it is there, right? And gap it is there. So if you have the energy that can increase the temperature, or maybe if you provide the light, electron can go from the valence band to the conduction band, right? So this is the recombination. When electron come from the higher energy level to the lower energy level, it can emit the light, or we can say it can emit the energy, right? So in insulator, the gap it is very large, that is about 3 electron volt. So that it is not possible, either you can provide the heat or it is not possible to provide the light, so that electron cannot go from the valence band to the conduction band. So in energy band gap structure for the typical solids are there, that is lithium, beryllium, and if you are considering the silicon, here we can understand this one, so that first we can understand this on the basis of the energy band diagram. As we have seen that in the case of sodium, the conduction band and valence band, these are overlapped, right? So it is a metal. But lithium, if you are considering, it belongs to the group first, 1s2 and 2s1 it is there. And it belongs to the K shell. Here you can say these are the 3 electrons, right? 2 n electrons are there in the 1s2 and 3s1 it is having 1 electron, right? So we can see whether it is metal or semiconductor. As requirement it is there completely filled level, and adjacent to that one empty levels are there. And then 2s1 it is there. Here inside this one it is completely filled, 2s2, and 3s1 it is this one is half filled. So that requirement it can be fulfilled. So that solid of group first elements are characterized by half-filled bands, and these are the conductors. But if you think about the beryllium, it belongs to the group 2 alkaline earth element, and you can see electronic configuration of 1s2 and 2s2. That is the insulator, right? Just a minute.
बोला sir, please.
Yes. Just 1 minute. So here it should be 2s2, 1s2 and 2s2 it is there. It is completely filled. Then we can think this may be insulator, but it is not. It is a metal. So 1 minute. So it should be insulator, but it is a metal, because here we can understand this is a metal, right? Here we can say 1s2, 2s2, 2p6 it is there, and 2s2, 2p6 there is the overlapping of the band it is there, right? So it is filled level and empty level, it is complete, and overlapping it is there. And because of the overlapping, we can see that this beryllium, it is having completely filled 2s band and completely filled vacant band it is there. Because of the overlapping, we can see that this is a metal, not an insulator. And this overlapping, it takes place in case of beryllium solid, right? So overlap it is there, formation of the partially filled hybrid band, and these are the conductors. Then if you are considering the silicon, then we can have the electronic configuration that is 14, that is 1s2, 2s2, 2p6, and 3s2 and 3p2 it is there. Right. If you have the 1s2, 2s2, 2p6, these are the completely filled, and you can see that 3s2 and 3p2 it is there. Right. And these two levels are there which are responsible for the silicon to become as a conductor. And here you can see this is the atomic interaction spacing it is there. Right. So here n level, 3n levels are there, and diminishing spacing, composite band 4n electrons are there, 2n 4n states are there, 0 electrons, 4n states are there, 4 electrons are there. And important thing is that this is the gap which occurs between completely empty conduction band and completely filled valence band it is there. And because of this gap, the silicon acts as a semiconductor, and this is the atomic interaction. If you take the actual spacing of this atom at this place, this can be metal. But if you see actual atomic spacing for the silicon, it lies at this stage, so that you can see that this silicon, it is a semiconductor because there is a gap, and this gap for the silicon, it is about 1.1 electron volt. Right, so that this is the valence band, this is the conduction band, and there is an empty stage it is there between this valence band and conduction band, and this gives the silicon as a semiconductor. So here we can take the assignment for the carbon, that carbon it is having 6 electrons, right? Then on the basis of the energy band diagram, can you distinguish that carbon it is graphite and diamond belongs to the carbon? Then can we define the conductivity depending upon the energy band diagram, whether graphite that is the conductor and diamond can be insulator, but belongs to the same carbon on the basis of the energy band diagram, and that we can do the assignment, right? Sir, only 3 minutes left.
Yes, sir. Continue करा सर काय
हा सर, मला आणखीन एक मीटिंग आहे आता 10:40 ला.
हो सर, तुम्ही मला म्हटलं होतं सर कंटिन्यू करा. थांबायचं का?
हा थांबूया, आणि राहिलेला अजून पार्ट, अर्धा पार्ट आहे.
बर चालेल सर. काय
अर्धा पार्ट आहे, मग अजून एक आपल्याला 30-35 मिनिटं लागेल.
बर काय हरकत नाही सर, तुमची मीटिंग आहे, थांबूया, काय हरकत नाही.
हा चालेल.
थँक्यू सर.
ओके.
ऑडियन्स मधून कोणाला काही क्युरीज असतील तर आपण विचारू शकता.
हॅलो. हा विचारू शकता.
3 मिनिटं आहेत, 3 मिनिटात लवकर आपला प्रश्न शॉर्टकट मध्ये विचारायचा आहे प्लीज, फ्रॉम स्टुडंट साइड.
2च मिनिटं राहिलेली आहेत.
ओके. जयस्वाल सर. अभय चित्ते सर.
हो सर.
सरांना अनम्यूट कर ना, प्राचार्यांना.
हो केलं.
जयस्वाल सर.
Thank you, Dr. Sabkar sir, for delivering a very beautiful lecture and informative lecture. Certainly it will be helpful for our students during the period. On the behalf of college, I extend my gratitude to Dr. Sabkar, who delivered a very useful lecture for our students. Extend my gratitude to Dr. R.S. Patil and Dr. Ahire sir, principal from Shahada College and principal from A.C.S, for their valuable presence in this webinar. And I conclude, the session is over. Thanks to all.
Okay, thank you, sir.
Thank you, sir. Thank you. Sir.
Oh,
Close the meeting.
Oh, sir.
Meeting close.